What did she say right there? Jill's line is steeper than Jack's, right? Let's go and put that. So Jill's line is steeper than Jack's. Why do you think it's steeper than Jack's? Yes. Since Jill has a greater slope, right? She has that greater rate of change. So Jill's line is going to be steeper than Jack's because she is traveling at a faster rate, right? So did what we know about slope and just looking at the equation, we get to verify it graphically now? Right? We know, we looked, like right here, we said this, that she's traveling at a faster rate. We know 55 is greater than 35. So we know that this line should have been steeper. And is it steeper? Right? Think about roller coasters. You're just going up real slow and gradual, taking your time. This one shoots up faster. Okay? So I always like roller coasters. They help me think about what would be the steepest. Okay? What is the y-intercept of each graph?
0,
0, 0, right? So they cross at the origin. What is the x-intercept of each graph?
0,
0, 0, right? Good job. What's the slope for Jack?
35.
And what's the slope for Jill? 35. Is this data continuous or discrete?
It's continuous.
Why were we allowed to connect it like we did? It says change over time.
Because you could mark your distance like between or like whatever time.
Yes, right? Is time continuous? If I wanted to travel for 30 minutes or 45 or 66 minutes, could I have done that? Right? I don't have to just only travel for 1, 2, 3, and that's it, and 4. Okay? And then also with my distance, can that be continuous, right? Depending on where I stop, I could have traveled 101.2 miles or 106. It can be anywhere in between. So it is continuous because both my time and my distance are also continuous. So do you see how it's bringing that back in as well, right? None of that is leaving us from the very last unit. It's always going to be looping back in because it's going to determine. What type of functions are these? What type of functions are these? Talk with your group. Give me an answer. What type of function are these? Okay, but Lena, what type of functions are these? Linear. Does everybody agree? Why is it linear? Yes.
Straight line and it goes to the origin.
Straight line. But does it have to go through the origin to be linear? No, it doesn't have to go through the origin to be linear, so we don't have to state that. It's because it is a line. The graph is a line. Okay? Any questions on this? Wrapping everything up and identifying key features. Okay, now let's go to student drivers. It's on the other side. Ms. Hell has 12 students in her classroom. Some of her students may have a driver's license and some of her students may not have a driver's license. Create a table showing the possible combinations of students with and without a driver's license. Then graph the data. Be sure to appropriately label your graph. So can I have a person up here to come volunteer to complete my table with the class? Who did I see first? Melanie, go ahead and go. Okay. No, you're not. Excuse me. Okay.
So first we're gonna have to figure out okay, so one side's gonna have to have students and one's gonna have without, so you mind whichever one's on what side.
Okay, let's go and start with students with. And students without? Okay, and we'll start with 0 students.
Okay, so if there are 0 students with a driver's license, the rest of the class is gonna would not have a driver's license.
So how many would not have them then? 12, right?
And then at the bottom of the graph, you can just flip it, since it would be the opposite. So it would be 12 and 0.
Does everybody agree on that?
Yes.
Okay.
Okay. And then there would be, besides 12 and 0, there'd be 11 and 1. So there'd
So when one student has one,
be 11. And then the opposite for the bottom. And then 10 and 2. So like 2 students with a license, 10 without.
what are we noticing? What's the total always equaling horizontally? 12, right? Because we have 12 students.
And then the same at the bottom. And then there would be 3 and then 9. And then 9 at 3 at the bottom. So, and there would be 4. You can just fill it out like this. So 4 to get to 12, that would be 8. Simple. And then 5 to get to 12, 7. And then 6 is just, it's 6 times.
Does 6 have it and 6 don't, right?
And then this is really where, once you hit the 6, everything's just going to be repeating. So it'll be 7, 5, and then 8, and 4, and 5.
Everybody good with her table? Right there, right? Okay, good job. Now I need someone to go fill out my table. Regina? Yeah, just making sure y'all do. Graph. Okay?
Okay, so first we're going to label our graph. So the x, it would be, since we're going to label this x, and then y.
Good job.
Okay, so for the x, this is going to be the students with driver's license.
And you can put DL. You don't just fill out.
Okay,
Students with DL.
and then this one's going to be students without. Okay, and then title of our graph, we're just gonna put student's driver's license. You don't like that title? Okay, so now we have a lot of dashes under, so we're gonna have to label them. So let's this 1, 2, 3, 4, 5, 6, 7, 8. You can't really see it. 10, 11, and 12. And then we're gonna do the same for this way. So just let me do it real quick.
Go back to Judy's.
Oh yeah, we could go by 3s, but I don't know where.
It's good to go by ones, but you're saying that you could label every 3 so that you don't have like a lot of numbers, right? So like every third mark put a 3, then every third 6, 9, 12, right?
Yes.
But then
Okay.
in between they'd all still be going by 1, right? Okay.
You can tell where it is.
Yeah, very good.
So now, when we look, we see the students without driver's license, it starts at 0, and then the students without driver's license, they have 12, so it's going to go up. We have our first point there. And then we go to 1 and 11. 1, that's 11. 2, that's 10. 3, that's 9. 4, that's 8. And then 5, that's 7. 6, that's 6. And then 7, that's 5. 8, that's 4. 9, that's 3. 10, is 2. 11, 1. And then 12, of course, is 0.
Perfect. Everybody agree? Okay, good job. Thank you. Okay. Now let's look at number 1. Okay? What does the ordered pair 0, 12 represent in this situation? So first, where do we find 0, 12 on this graph? Okay, so my mind is, let's get another color and let's circle that. So then what would 0, 12 be? What is that known as then, Mia?
The y-intercept.
Y-intercept, good job. So this is my y-intercept. Now I want to know, what does 0, 12 represent in this situation? What is the 0? What place is the 0 in? The x, so what does that mean? So student, okay, and then what does 12 mean?
None of them have a driver's license.
Without, right? So then put this in a sentence. What does 0, 12 mean? What do you think it means? Raise your hand, let me know before you write. Maria.
None of the students in the class have a driver's license.
None of the students will, let's be specific, how many of them? Mia.
So if none of the students have a driver's license, then
Yeah, you're all right. If none of the students have a driver's license, then there are
there are 12.
12 without, right? Okay, so there are 12 students without a driver's license. We all agree on that? So we want to put the number to be specific. Without a DL. And Maria was right, there are some students who don't, but we want to be specific because we know that number, there are 12 that do not have one, right? Okay, now what does the ordered pair 12-0 represent? Where do I find this on my graph now? Okay, so let's go and circle that. So then what would that be? What part would that be? Yes, Sophia?
There are 12 students with a driver's license.
12 students with the driver's license, everybody agree? Okay, so 12 students with a driver's license. And then what, like mathematically, what is 12-0? The x-intercept, good job. Okay. Now, does it make sense to draw a line to the points in this situation?
No.
Okay, you're all saying no. Why? Yes, Madison. I cannot have half a drive. Well, it's half a student, right? Because if we connect it, we're making it what type of graph? Continuous. But right now, what is this data? Discrete. And the reason being because we can't have half a what? We can't have half a student, right? So this is discrete because we can't have half a student. It's really